Hello everyone, today we'll be discussing substitution versus elimination reaction. Substitution and elimination reaction are two reactions that are always in competition with each other. This is because the reagent that carries out this conversion can either function as a nucleophile in substitution reaction and can also function as a base in an elimination reaction. There are three major factors that can predict the products that will be formed when an alkyl halide reacts with the reagent. One of the factors is the function of the reagent. The reagent that carries out this conversion, does it function as a base or does it act as a nucleophile? Then another important factor is the nature of the substrate. The nature of the substrate also affects whether the reaction will proceed via substitution or elimination reaction. In the nature of the substrate, we have the primary, the secondary, and the tertiary. Then also another important factor that can determine the product of a reaction, whether it will proceed through substitution or elimination, is the reaction condition, which is usually high temperature. When we consider the function of the reagent, there are some reagents that can only act as a nucleophile. Examples include the chloride ion, the bromide ion, the iodide ion, the sulfide ion, the hydrogen sulfide, and the thiols. These reagents mainly function as a nucleophile. So whenever you see them in a reaction, they react via substitution reactions. Let us consider this example below. This is a primary alkyl halide. The primary alkyl halide is undergoing substitution reaction with sodium bromide, which is a source of bromide ion, to give the substitution product via SN2 mechanism. The nature of the substrate. This is a primary alkyl substrate, and this sodium bromide, which is a source of bromide ion, function as a nucleophile. So it will undergo reaction by substitution, but not elimination. Another example is the reaction of tertiary alkyl substrate with the source of nucleophile, which is sodium bromide, to give a substitution product via SN1. So this reagent function as a nucleophile. That is one point. Another important factor that accounts for the difference in the substitution reaction is the nature of the alkyl substrate. Here, the primary undergo reaction via SN2, but here we have the tertiary alkyl substrate, which undergoes substitution reaction via SN1. But the two reactions are substitution reactions because of the nature of the reagent used. For bases only, we have the hydride ion and the tertiary butoxide. These reagents function as a base only. So whenever you encounter them in a reaction between the alkyl halide and this reagent, it will only proceed through elimination reactions rather. Because hydride ion and potassium tertiary butoxide are very strong bases, they proceed through E2 reaction irrespective of the substrate used. Some reagents can also function as a strong base and also as a strong nucleophile. Examples are the alkoxide ion and the hydroxide ion. Because these reagents can function as a strong base and also as a strong nucleophile, we have the possibility of getting more than one product. For example, using this primary substrate with a very strong base and also a very strong nucleophile, we obtain an SN2 product as the major product and also an E2 product as the minor product. We obtain the SN2 as the major product because of the nature of the substrate used, which is the primary alkyl halide. But when we use a sterically hindered base in the primary substrate, base like the potassium tertiary butoxide, we obtain the substitution product via SN2 as the minor product and the elimination product via E2 as the major product because of sterics. When a secondary substrate is used, like a secondary alkyl halide, is used with a reagent that can function as a strong nucleophile and also as a strong base. We obtain the E2 product as the major product and the SN2 substitution product as the minor product due to sterics. For weak nucleophile bases, this reagent act as a weak nucleophile. They can also act as a weak base. For primary alkyl substrates, they do not undergo SN2 reaction with weak base or weak nucleophile because the reaction is extremely slow. As earlier stated, the primary alkyl halides usually undergo substitution reaction via SN2 and also elimination reaction via E2. But for weak nucleophile bases, SN2 reaction is not possible because the nucleophile is weak, which makes the reaction to be extremely slow, leading to no product formed. For reagents that acts as a weak nucleophile base, example, we have the alcohol, we have the water, and sometimes we have the pyridine. This reaction usually proceeds via SN1 and E1 mechanism. We often observe E1 mechanism when the substrate is treated with an acid and at a very high temperature. And also we often observe SN1 mechanism when the substrate is just treated with heat and the nucleophile. Secondary alkyl halide. When treated with a weak nucleophile or a weak base, we observe mixtures of products which include the XN1 products, the SN2 products, the E2 products, and the E1 product. Thank you so much for making our time to watch and listen to my video. Please, if you like what you watched, please like, subscribe, and share. And if you have anything that can better this video, any comment or any contribution, please feel free to leave your comments in the comment section. Thank you.